the first sponsor that we had as part of the Center of Excellence. We expect that this is the first step of a much bigger improving of digitalization in civil engineering, because all of you that are here, we expect you to become part of the community of such a big part of the new developments that we will be having in civil engineering. Just to let you know, we think of you as top-notch learners and top-notch professionals for the next years. We know that the previous cohorts have been quite important in their companies, and we expect you to be part of this improvement for the new decades. From my part, I would also like to tell you that nowadays we are seeking to start promoting the next year. So we ask you to be as loud as possible in social media, because we think that this digitalization target is going to be a key for the European Union in the next years. From my part, I would like to take more time from the speakers, so I will leave the floor to them. Thanks a lot for that.
Thank you, Alex. Let's jump right to the keynote lecture on the stage and the context. So I'm very pleased to welcome Christine Lebrun from Eventbrite on stage. So Christine holds a PhD in electronics and telecommunications from INSA, Rennes. After working for 20 companies in both optical and mobile communications, you decided to change and move to an architect studio, which is original, but very interesting move, exactly. Where you assisted the architect in all customer partner situation relationships. Then, considering your experiences, you joined a visual model. Another aspect, interesting. To build a smart building program, building relationships between the IT and construction sectors. You to Seattle, a world leader in digital twins for cities, where you were responsible of smart territory solutions. Now, your point, a leader in smart cities and places, you act as an expert in digital twins, platforms, and territorial data evolution. Your main interests are using data and IT at their best and further in promoting solutions about that user usefulness and being conscious of their environmental costs. And in addition, she used to teach in the executive master for a time. Thank you again, and the floor is yours, Christine.
Thank you, Mathieu, and I'm really very pleased very pleased to be with you this morning. Just a few words maybe about OnePoint that you may not very aware about. OnePoint is a big company, French and privately held company. We are about 4,000 people at OnePoint. And you have some figures there, but what is very important is that we are very focused also on environment and social aspects. The main aspect being that we are certified to go and take over this platform from this very. What do we do at OnePoint? OnePoint is a digital transformation company. But we work on the whole chain of value, meaning that we work from perspective very high at the beginning of the project, making R&D, prospective, studies, benchmarks, etc. And we also work on strategy, so this is work counseling. And then we do also, so that we are a digital transformation company, so we develop applications. We work on cloud, on secure security, etc., maintain also projects. But something that is more uncommon about OnePoint is that we have multiple links with the education and research world. Many schools, universities in France and larger than that. Because we strongly think that there is a pool of innovation and knowledge that is of great value for us in working with the research and the education work. So we have these two entities, l'Institut, we call it l'Institut. This is our R&D entity, where we have a couple of PhD clients and also many partnerships. There is one of them with me today, Mustafa, you may have met him. And we have the École, which is the school, and this is where we teach about digital transformation, digital tools, technologies, AI, cybersecurity, data, etc. for us, for our collaborators, but also for our customers. So then let's talk about urban planning from now and beyond. When we talk about urban planning and how cities have to transform in the coming years, there are three families of challenges. So Mathieu said it, many challenges. I like to have these three families. The first one is about buildings and infrastructures, because we really need densification and renovation of the buildings together with mobility, utilities, and of course the waste management. Then there is all the social aspect of things. We have an aging population and inclusion issues, the quality of public service, etc., etc. And of course, maybe the most important of that is the environment, with all the issues of decarbonization, energy transition, and the preservation of biodiversity and the natural resource. And of course, in that, the subject of climate change adaptation comes to us more and more, and becomes more and more a subject also for the cities we are working with. And to that, a small remark about the climate change adaptation is that the regulation framework also needs to adapt, not only the city. Currently, the regulation, like in France, PLUI, tell you what you can construct or not, and where. But however, all the events and the constraints that are brought by climate change are not very well described in those PLUIs, and all the reference functions. Why is that? Is that because adaptation is quite a new concept. So it has to evolve, and this is a complex political aspect. But last week I met the metropolis of Aix-Marseille, and I was very pleased to hear that they just launched a program that brings together the problem of adaptation and how you evaluate the cost of non-adaptation, together with the people from the PLUI, so that they work together on reflection of how you can evolve the PLUI in order to integrate adaptation subjects into the future regulation. So that's, I think, very inspiring from a big metropolis like that. So the problem is that this system is not, of course, only a matter of the number of topics or even their complexity taken one by one. The problem is that they are very highly intricate. And now you cannot talk about mobility without considering energy transition and carbon footprint. You cannot anymore talk about urban layout without talking of social mixity, urban heat island, and public health. So this becomes also very difficult because you have many stakeholders, and this is from the different administrative layers to technical partners, urbanists, architects, associations, and not forgetting, of course, the population. So it remains very challenging to, even if there is more collaboration, but it remains very challenging. And even if you have tools like BIM or like participative democratic platforms, there is a lot of improvement to come. So before talking of solutions and even tools, I would like to have a little step back and think about what could be a framework to take all of this into account. Well, it's quite early and still early, and I think you're not too hungry, so I made a risk losing everyone. And this example is quite interesting because Amsterdam took this step aside to think about how to draw quite simple guidelines and to help them keep a direction when they thought about transformation at a global point of view. This donut example is interesting because I don't know if I have a pointer.
Yeah.
Like this.
In the middle.
Okay.
You have to do it.
I have to do it. Yeah, here. This you have a tool. This is a compass. It is inspired from the UN work, and it works with two compasses, one in the middle and one here at the exterior. The first one is the social foundation. It means what is essential for life from a social point of view: the food, the gender, education, justice, etc., etc. The goal is that no one should be here in the middle, but here at the edge of this first circle. And the other one, the other compass, the outer compass, is the ecological ceiling. So this is from the Earth, the world point of view. And here there are 9 planets boundaries, like freshwater, like biodiversity, like climate, etc. So you should stay here in the middle if you want that you have a just and ecologically safe world. So this is the theory, and what they did is that they tried to represent what is the state of the world today. So when you have red wedges, that means here from under the social foundation. That means that it is where you have proportion of the population that don't meet these kind of needs. And from the planetary boundaries, then that means that you are here overshooting these boundaries. And at first, climate change, we are really very, very bad. We are bad also in biodiversity and also land conversion and some kind of pollution. So the challenge here is that we should move within the donut from both sides if we want to have a safe world and something that guarantees the well-being of people and the health of the whole planet. And of course, the cities that gather like a very, very high part of the population, 70% in 2050, of course, should be a leader in that direction. So where shall we start and how can we proceed? Of course, it's not only a matter of urban planning, but many of the topics mentioned before are also addressed in planning. So I like this representation that I took from a recent article on urban process and AI. It shows the various components that should be addressed. There is the physical playground, the buildings, the infrastructure, the vegetation, etc. So that's objects that shape the space. Then there are the people, the users. That means residents
students, operators, companies. This is the social component. And those people, they are students, families, workers. They are also elderly people, and the way they use the city and its service, this is the functional component. And all this doesn't work in layers, but in a circular approach. And I would like to add to that, you have to also to consider the impact of that on the environment, on economy. And you have the economical equation, of course, because we need money to do that. And so this is where we have the very, very multidimensional urban planning problem. And for me, the other aspect that is most important is that we need collaboration between all the stakeholders, including citizens. Now we have an idea of the problem, which promises terrible headaches, with impossible compromises, and endless discussions between the parties. And of course, we dream of smart digital tools to help us to succeed and to do smart things. Does that kind of tool exist? No. But we could be tempted to think about one tool that could do everything, concentrate all those dimensions, cover every topic. But in my mind, it's not that it's not possible, but it's not very smart because it's too complex, it would be too costly, very difficult to use, because hundreds of parameters, and of course difficult to maintain. I prefer, and I saw in my various missions, other approach, a more collaborative approach. Because the problem is so complex that you need real expertise to address everything. And this expertise must be combined by having expert tools that you can interoperate, that can exchange information. And since you have to exchange information, this is where you are starting to talk about data, because the tools must be interconnected, exchange data, information, and to do that, they have to have a common referential and be well governed. And so, because for example, we can have one tool that calculates something, and the results of this calculation goes into another one, etc., etc. And of course, that kind of tool, that could be the digital twin. I will not make here a lecture on digital twin because we know many things about that. But just to recall the way I see digital twin. For me, it's a good content candidate as a data provider. Why? Because it's meant to do so. It's meant to be a referential that is shared between stakeholders. It contains data on various topics, and that data can be crawled depending on the subject you want to study. For example, if you look at buildings, you can consider them from their geometric shape, but also from their history, their cost of construction, their occupancy, their carbon footprint, or real-time energy consumption. And this digital twin also evolves from time to time in the way the city evolves to. It's like an avatar. You can play with it, modify it, and see what happens. So it's a good solution to first understand the city and also understand how it works and how it can evolve. And in order that this works, of course, the digital twin itself must be interoperable so that the data it holds can be trusted and can be used to other tools, for example, simulators, to address a very specific topic. Now, is there a place for AI in there, and especially generative AI? Just this diagram, just for a little reminder, is that AI is already there and has been for a long time. The thing is that before, when as AI algorithms improved, they got more complex, and they got also more complex to understand, to appropriate. But with generative AI, it's not the same. You can see it here. So this here is the value, the performance of the algorithms, but the complexity is more complex when the algorithms. But then here now you have more capability of AI, but the complexity of appropriation goes back here. So it's not only that generative AI is powerful, but it's powerful and simple to use. So that's why now, when we talk about AI, everyone thinks it's generative AI, but there are many other things, any AI algorithms that are used, and here is one of them. And in urban planning, there are many examples. So one is the machine learning. The machine learning describes algorithms that can recognize patterns automatically after they have been trained on a large amount of data set, and they have to teach what they have to look for. This is widely used to process aerial or satellite images in order to detect different kinds of objects like buildings or vegetation, and from that to draw maps. So that's an example here for land use classification, but there are many other applications. Then there are the predictive models. This is like a kind of further step of machine learning. It's not only a matter of detecting something, but create a model that represents the way the system is functioning. It learns from historical data and scenarios, and then you can alter the input parameters with other scenarios, and then you can test and simulate what happens. It's basically the way weather predictions work. Here you have an example for the population of Helsinki, a projection of this population, and how it is likely to evolve depending on urban planning choices. It allows to better understand the consequences of those choices before making them in real life. Basically, potentially identify the risk of overcrowding or the lack of infrastructure. If you see this in the simulation, then you can modify and adapt the scenarios. Now, if we talk about generative AI, what is the potential of LLM, VLM, and agents? It has much potential. Why? Because it is increasingly transdisciplinary. That means that you can integrate many kinds of topics within a single model. And it doesn't have the problem of addressing only one topic. It is able also to have smart and reasoning abilities, and to propose solutions, to propose ideas. You can extend in multimodal kind of working to generate text, images, maps, and to analyze also all at the same time that kind of material. You can interact with it, so it is very participative from nature. And with agents and automation, you have also the possibility to organize things and to distribute tasks in order to solve a problem. Just to help you understand the potential of agents, because you're not maybe very familiar, I proposed three diagrams. Here is the AI assistant. This is ChatGPT. But the way it works is like, very often we like to describe it as a trainee who waits for clear instructions and then he answers. So that's why when you use assistants like this, you need to prompt and you have to be good in your prompting, otherwise he answers something that is not adequate. When we arrive to agents is more performing. Agent is like an autonomous employee you have in your company and to whom you delegate a specific task. And this agent doesn't work alone. He can also use resources like tools or like databases, and he can interact with you, the assistant, but he can also be very autonomous and be activated by a trigger. That means every day, every 3 minutes, or whatever you want, but it's a trigger. And then the agentic workflow, then it's like you have a whole project team working together, orchestrated, organized, and also interacting with you, but which have a way to work at activating various agents, so the same as above, but one agent for one task and one orchestrator who organizes everything, and the whole thing can handle very, very, very complex tasks without having to come back to the human person here. So this is the description. So then, what are the tasks in urban planning? That's where LLM, VLM agents can come and bring something. Here's an example I got from a recent paper that could make sense, but of course it's only a way to see things, and you make things different and it can be challenged. LLM, since you have this natural language, you can interact with the model, could be used to the first stages, to draw concepts, to make diagrams, but to express ideas, to bring together concepts, constraints, and guidelines, and then from that, imagine the way you could treat the problem. This is where you could bring in the donut, for example. I want a city that, no. Then, once you have done that, you could use the VLM to generate. That means to then draft the plans and try to see what it could be in the real life, including 3D. And here, since the VLM can integrate the results from the above step, then you can integrate various concepts together with some constraints. And then in the end, once you have generated your ID and your urban profile with all these characteristics and parameters, you can evaluate them using agents, more complex agents that would integrate some scenarios, make simulations, and see how the concept works and how it has some impact on environment, on social, etc. The next step could be, well, we could dream or not, of a super agent that could study a planning problem from all angles. This is a really nice diagram. Here you have the user. So this is a human, but there it's all like a family of agents that have some different tasks to do, referring to different topics or different aspects of planning. Here I have my users with his requirements, what he wants to do, the concept and his problem that he has to describe. But then you have a planner. This is the orchestrator that I showed before. And then the planner will distribute some constraints to this agent, some constraints to this agent, etc., etc. And then each of them is the expert of his topic. And then once everyone has worked on his own problem, then there is another agent that makes the gathering of all the results. And then here we generate something and we obtain a result with metrics, with etc., etc. And then from that, you can come back to here, my user, with whom you can the AI discusses. And like here, it's like in GPT, I prefer this and that, no, this is not very good, and then do it again, etc. This is this is the way it could be organized using very specialized agents that work together, but also interact with humans. And here, maybe you connect with what we said at the very beginning about the need for interoperable tools that should be linked together in order to address globally all the components and challenges of planning. And if this is possible, then you have a way to get a multidimensional vision and a way to work interactively and also dynamically with someone you can exchange with. And when I say someone, it's a machine, but like a whole team working with you. And of course, here it's not you only, but everywhere here. Since this is agents, we can also have here some humans. But this is a concept that we are not here yet, but there are many teams working on that in the world. We at one point we are working on it too. This is the work of Mustafa for his PhD, and I thank him for pointing me some papers. I put the references. Sorry, I put the references everywhere. Because some of them were quite inspiring. As a conclusion, a little bit late, of course I'm not here to tell that AI is magical and will solve everything. Not at all, but it's a really interesting perspective. However, there are some things I wanted to point and things that need to pay attention to. First of all is that what we see all the time in our AI projects is that no data, no AI. Data is at the heart of everything. AI is its models, and the models to exist first and then to be used, they need data to be fed with. So this is and this data, of course, must be of high quality, must be secure, and can be shared. And on this topic of being shared, Um, the local authority, from my point of view, has a role to play because in urban planning, the final goal is citizens, is the quality of the city, and it must be a desirable future. So the local authority may be the one that federates everyone so that all this works together. First thing, the resources. All these models are very costly to train, and since we have complex problem, it's complex model. So the way we should do things is to work on specialized and smaller models dedicated to specific tasks. So CF, the diagram before, like cut the big problem in small problem, each small problem, one agent, one specialized model. This is more economic, not so costly to do. In energy, also in bureau partners. Fourth thing, bias. The models learn what you teach them. And there is a risk in urban planning that when you design the models, you use data that are over-representing big cities. Then the models, they are based on those representations of big cities. And so they are not adapted, they will not be adapted to any kind of environment. Same thing for gender, for race, for socio-economical parameters, like in every kind of model. So a very participative approach in the training is necessary. And last thing is validation. Of course, we need to study various cases to test the models, otherwise they will not work very well. And to do this, you must, again, include all the stakeholders in order to guarantee that. So thank you. I would like to thank you for the attention, and hope this is a good insight for you. Thank you.
Yes, thank you, Christine. Very interesting. We have time for some questions. If you have some, please, you can raise your hand. And I think online, maybe also, if you want to ask some questions, feel free. I can start with one, because I told you at the end, it's a lot of technical aspect. But in the end, about local cities or territories, counties, etc., come back to topics. And timeline for topics are not the same as timeline for technical aspect. So how do you deal and then can you convince politics, which in the end decide actually to implement some solutions? But sometimes they have the vision like short vision about elections and these kind of things. So how can you manage?
You mean about AI or
the use of no, the use, and if you, I don't know, in your missions, if you want to help cities, you mentioned ex-Marseille. How do they, because it does take time, I think.
Yeah, it's a daily challenge because the long-term vision, of course, they don't have it very, they may have it, but it's not the priority. And so it's really very difficult, and sometimes we can count on some mayors or some people who have that vision. For example, at Angers, they were one of the first of French cities building a digital twin. And his mayor, Christophe Béchu, had really this vision. He didn't know at all what he could do with a digital twin, but he wanted one because he was feeling that there was potential. However, their teams, they were not aware at all. So when we started the project, and okay, we have digital twin, but what do we do with that? So this is, you have to deal with every day, and it's, I have no solution about that. This is thing is not trying to explain.
Okay, it's what it is.
Yeah.
Any questions, remark? Yes. I don't know how to let you open you.
Thank you, Christine. One question. Do you think AI and data twins can help us with the with the adaptation to the climate change, but also with the mitigation of the climate change?
Yes, sure, because they first they can help to understand what happens, and they can also help to gather all information about what historical events, but also for prediction. So where AI exactly could be used, I have no answer right now, but in planning, using various types of constraints that are regulation, that are social information, economical information. Some models, since they are multidimensional, they will help to gather all those constraints together within one model, and this is sure one possibility that is very interesting.
Yeah, absolutely.
Well, congratulations for the topic. I find it very interesting. But I was wondering if you have tried this methodology in places like in Paris, where urban planning is very limited and there's not as much space in general to construct or plan anything. If you arrive to any conclusion with, if you try it, if the model arrives to any conclusion.
No, we don't. The things I show here, it's more like perspective and the way to see things and the way things could evolve in the future, including AI agents, etc. In Paris, yeah, it's complex. You have the land that is available is very scarce, but there are possibilities, and a way to work is to identify where are those spots you can tomorrow build, but maybe build also higher, because you have to spare the land to spare the natural resources too, and then with algorithms very specified, special algorithms, then we can test many solutions, like multiplying the scenarios, and I think this could help, but today it's ongoing work for the techniques, for sure.
Good morning. Thanks a lot for the presentation. One question back to the algorithms. In terms of urban planning or buildings and construction, there's a lot of physical modeling already existing. When you describe this type of methods, is it data science plus combining this type of physical models, or is it pure and full data science without any knowledge of physical modeling?
No, it's physical modeling and data science. You cannot make predictive models without having physical models.
only the data science, but the thing is that I'm not a technical specialist of algorithm, but the thing that I can feel is that automated AI will be able to combine data science modeling, because one agent could handle one kind of model and combine, and the orchestrator could combine that in a whole system, and somewhere in the system you may have data science for conversions, for analytics, for representation, anywhere. But for me, you need to have physical modeling for climate, for example, for pollution, so this is still necessary.
We're talking a lot about testing and simulation and all these things, but I'm curious, like, did you ever get to see an example of things being done? Because I feel like changes are happening so fast, there's like storms and floods and droughts happening right now.
Yeah.
Did you ever get to see an example of the city being, okay, let's try something, let's test something out, given the modeling we've done, or we're still looking at testing phases for the most part?
You mean, is there an example somewhere a city has done that?
That's taken whatever conclusion they have from the data and from the models to try something actually like for easy.
From the model, I don't know, but from the data, I know that Amsterdam has done things. When they had the flooding, they had the big flooding, and I think it's in 2011 or 2017, they had a major flooding, and then they used big data analysis in order to understand from where the water was coming and why it has been stuck everywhere in the city, and all from the shape of the buildings, the shape of the streets, and they built a model of how the water was flooding in the city, and from that they built like a plan of digitalization of the city. They really transform things, building spaces, special spaces where the water can be stored, and this is digitalized, so the water, the vegetation keeps the water and renders it later on. So that's why Amsterdam is called the sponge city. And so this whole thing of analyzing what happened, design model, and from that imagine where I can change things in order that the water is retained, this is something very interesting. I wrote an article on that in Smart Citizens. It's in French. So. Okay.
Where's the microphone? Thank you, Christine. We can keep her then. Actually, we're but I have the time keeper here, so we jump to the second lecture this morning by Michaela from the T-System. So this is the remote. And so thank you, Michaela. So you are a vertically modeling subject matter expert at Bentley Systems, where you support users worldwide in advancing their technical skills and contributing to an innovative and collaborative community. And your expertise spans mobile, terrestrial, and aerial mapping, photogrammetry, GIS, scalable geoinformatics workflows for global clients, and AI-driven analytics and management of climate data for digital twins. and the topic is about unproductive employees with reality data. The floor is yours. Thank you.
Thank you very much. So once again, my name is Mihaela. I am a subject matter expert in benefit systems, and I'm very happy to be here. First of all, because we have a headquarters in Paris that has its brain, its fundamental brain, in reality data. It is where some of the, what we call level of detail mesh, 3D mesh in the market, it is created by our users. And it is one of the best in the market, so we should start by that. This is happening here in Paris, in Gare de Lyon, in the center. This is where the team creates the solution. Inside Bentley, we have a lot of solutions. And we are going to focus today on digital twin and reality data. You should know that reality data, it is not acquired by Bentley. So reality data can be acquired by any of you here or elsewhere. And digital twin, it's something that we are going to define as a term, because maybe a digital twin for me is not the same as you or reality data. So my purpose today, because I was asked by my colleague Susie, to present something that it is easy to understand and to go further with real use cases that we have inside Bentley. You should know that all that is going to be listed here, they are use cases from real users. So the agenda of today is going to be data acquisition, how we acquire data, why we acquire data, what are the challenges, what are the workflows, what can we do with this data. So regarding about this, things about this is that we need to integrate the data. So we are going to discuss about workflows of reality data of a very high level standard point. We are not going to enter into details as the previous presentation, and this is not a theoretic model. It is real use cases. There are real use cases that are happening today from our users. And those use cases, in all the presentations, they are going to have data videos that were created by our users, by our clients, with our large table of solutions that we provide. I'm not going to discuss about any of the solutions. I'm going to discuss about high important terms and workflows. We are going to discuss about the physical assets. The physical asset is something that exists in the physical item. And this item has the possibility to change over time. And we are saying it is an item that is owned by somebody and that has a value, that can produce value. And this item is going to change through time. Let's take some examples that we are going also to see in some of our use cases. So we can have land, buildings, vehicles, furniture, equipment, so on. You name it. Here we have, as you can see, as a physical object, an asset. It is a bridge. We are going to focus on the bridge for the moment. Later on, we are going to have other type of assets. This physical asset is going to be developed, is going to have changes in time. Let's say that we want to see the clearance between the water and the high part, the structure of the bridge. This is for boats. Let's say that this is very important from another system that is going to be integrated with these physical assets. We can schedule some data. We can put some sensor on the bridge. Yes, when the water is going up, down, when we have floodings, and so on. We can have geospatial data. Let's say that it is divided into 2 territories, and we can have GIS data inside. So everything that is going to define this physical asset and is going to change in time, and from which we can have more data, is going to be called the digital twin. Understand the asset and how it is there in real life. We are going to focus a little bit on capture. As you can see in this diagram, you have the ground here. And in the ground, on the ground, we will have different types of devices that are going to acquire data. And here we are concentrating in mobile mapping, in backpack mapping, in photos taken by camera, or even by the cell phone. So all of these, they can capture data, which they are photos in 2D. And there is something about what we are saying to be called photogrammetry, one of the slides that I'm not going to define now, but very easily to understand. We are able to create 3D measurements, 3D assets, starting from 2D feeding data. So those devices are going to capture data, and this data is going to be reality data related to these physical assets. We are going to add the time. This is going to be our fourth time dimension. So we have 3D dimension, x, y, z, and then we are going to have the fourth one, time. Let's see this example of a mobile mapping. What is very important is that this is driven by somebody, and inside it might have also a device that is going to process the data that is coming from different systems that they are well structured and well known positioned in this mapping car. You are going to have a GNSS antenna and also maybe a flat display camera. Let's say that these are regular photos that you take with your phone. This is what we are called flat images. Then you can have 360-degree digital cameras, what we call panoramic images. You will have the laser scan. The laser scan is very precise because it has a system inside that is going to retrieve what we are calling the point cloud, X, Y, Z. So, this is very important because related to these assets, we will be able, just by drawing along the bridge, to make this as a digital twin, to have this reality data. But this reality data, as we said, point cloud, 360 images, flat images, they are going to be combined in order to be consumed and maybe to create analytics. But let's say here for this part. For this part, we are just getting raw data. For the moment, we are just here in the mobile mapping system where we are capturing data. We are not doing more than that for the moment. You will see later on in the workflow that this data needs to be processed, what we call it optimized, in order to be consumed afterwards for other users in a collaborative way. Let's go to the next slide. And here, we are going to advance a little bit. Here in the diagram, here, you will see that we are not representing anymore the ground, and we are going a little into the space in heights. So we have the ground, and the height represents exactly what you measure from this ground definition. Here, we are going to have at a very low level the drones. Of course, each country has its recommendations. And you should know that in France, because we are here starting with 2012, this has been regulated by the Direction de l'Aviation here in France, and you have 4 scenarios. And this is very important because it's very, it's modeled and it is under the authorities. There are other spaces that they are not yet defined, so this can also be another job from different students to discuss the legislations and to know how the drones that we want to use for production, they can be put it into space and how they can create different productions afterwards. Then of course you can have different other devices that are flying high in the sky for cargo and so on, different ways of creating those ones. And then you will have at a higher altitude airplanes. For the moment we are going to concentrate on this small space here. And by looking here, we will see a very common device that has been used lately. We have one of the producers that it's DJI that in the market that produces quite usable drones for different purposes. You should know in function of your purpose what you would like to use. Yes, for precision and accuracy, users are using what we call targets in the ground control points. And imagine the following. You have the images here that are taken at a certain height into the air, but those are what we are calling relatively positioned. So they are positioned one after the other. This is what this means. And in the photographic concepts, you are going to overlap images one after the other, and also in height, in latitude and longitude. And you are going from 2D images after all, using a process called photogrammetry, obtaining this 3D model that represents here, those houses. You should know that this one is a relative model. It's not related to where we are today, for example, in the globe. So let's say I'm going to create a photogrammetry process from here, yes, for this university. If I don't have any targets on the ground, or if I don't have a drone that has a system that we call RTK or TTK, real-time kinematics or post-processing kinematics, I will not be able to place myself really here in high level study here. So that's why it's very important for this reality data in function of what your digital twin will be afterwards to be in absolute frequency, meaning that I can really say that this house is here, that I can really say that Mihara is here nowadays, and I can measure different elements afterwards. So this is very important. In function of what you would like to do, you need to choose your data, and you need to choose your methodology and your workflow. We are going to define some terms. When we are flying over and when we are going to get different raster data, this is what we call raster or point clouds, so we are going to have different elements as meshes, 3D meshes, and this is very important because the images that we are capturing with data, they are geotagged, meaning that related to a certain device in space, let's call it a satellite, we are going to know where this image is positioned. Okay, it's fine, but this absolute, it is relative. Oh, yes, it is absolute because it's related to a certain, let's say, system that was defined before, what we call an ellipsoid. But what is very important, this is a mathematical model, and we are going to put it against a geoid. Now, the Earth is not flat, and we should have a lot of different ellipsoids. And also, something else that I'm going to tell you, a small trick here, is that you will see later on some tunnels, and in the tunnels, even this is not enough. So land surveyors and experts, they are going to create their own small geoids. Let's say in the Alps, they would like to unify the tunnels starting from Italy and going to France, and both countries are paying for this tunnel to unify in the middle. So in this case, they are going to create their own small geoid at scale with a local projection, meaning that there is a mathematical model behind that when they are going to advance, they are going to have millimetric precision, and the tunnel is going to be there precisely unified. So there are a lot of terms here, photogravity that are already defined. We have thermal imaging. Why is this very important? I had cases before in one company that is called Optometrics, and then also we have somebody here that is a supervisor project. So it is a drone department place, Optometrics, and they were, this is very important, they were looking with drones with thermal cameras for people that were stealing different elements from rails in the nights. So this is why the police was working very closely with this company, Optometrics, to fly a drone, long elevation drone, that is going to see the small people. They are going to see the cars because they have thermal heat. They are going to see the people that they were stealing those elements during the night. And this is how thermal imagery, but also because the images they were geotagged, the police knew instantly where to go and to find who was stealing and how. So this is another use case. We can have a lot of theoretical use cases, but we like more when we have use cases that they are real. So this is a point cloud. It's just telling us the surface, the XYZ of different points inside a certain asset. This is a representation, if you remember when I was showing you the mobile mapping, this is a 360 imagery, and this is a flat one. And this is very important because here trees they were detecting using AI. AI, this is another discussion. For the moment, even inside our company, there is not an AI that is going to be able to detect trees everywhere in the world. How is this working? We are feeding an AI detector, and based on some machine algorithms, they are going to, if data is labeled, meaning that I will say by digitizing it manually that this is a tree, and I will say how this is a tree. If it is well labeled, then in an environment that is very similar with this one, it's going to detect the trees. If I'm going to detect trees that are palm trees in Mexico, this is not going to work. So your AI detector will not work everywhere. In order to have that, we have the globe, we have different environments, we are not able to do that. So the Bentley approach today, that is not the approach that all the companies have, is that we are letting the user to train the data, and the user then runs the data on his data sets. And then, of course, there always will be 95% in the best case scenario of detection, but you need to test your results. So you need to see what is the accuracy of your results. This is what we call asset management. And always, this is a manual part of it. We are not yet where to say we have 100% accuracy. This is a general workflow. It's not something that we are doing precisely. So we have user data. It can be reality data, GIS data, survey data, point cloud meshes, images, 360, whatever it can be here, and CAD data. So we are acquiring the data, we need to establish which type of device we are going to use. This is very important because you can use the two of them, real mapping, mobile mapping, handheld mapping, and then we have different solutions that are going to integrate all this data into one centralized environment in order to avoid multiplicity of data. Then we are going to process this raw data. It's very important, this word of processing and processing to optimize the data. The data here that we have is not meant to live in a digital twin that has a part of sharing and consumption. Keep in mind this data should be optimized, and each environment should optimize their data in their own formats. It can be open source formats, which is easy to share, but also it can be other formats that are strictly property, that's the ones that we have inside Bentley, but later on we are trying to be more open community for the geospatial community. And then we have the end users that they want to see this data. Remember, the raw data cannot be directly seen by the larger user in, let's say, SaaS solution or web solution if the data is not optimized. And why we are doing this optimization? We are doing because we want to optimize the space, because we don't want duplication of data, because we want to increase transparency and collaboration, because we want to create a digital twin that can be seen from experts, but also from people that are taking decisions, from decision makers. So we want something that is very easy to understand. We have some challenges, as I was saying before, extreme volume, data. We have petabytes, we have terabytes, we have multiplicity. We don't want to have the same data everywhere. This is the unicity of digital twin, that all the data is not duplicated. We want to avoid manual works, and especially repetitive works, and also cold data. Cold data is data that is sitting in a hardware, for example, that is in an office, that is in a room that nobody knows where, and then we need to do something with the data. So those are the challenges, and they have been here for a long time. It's not something new, those challenges. We are becoming better, but this is coming with costs. So if we want to have a living digital twin, we need to be in the loop of design, construct, operate, and maintain. So, like this, we reduce time, reduce productivity, and so on. So we will have an up-to-date digital twin. Let's take some use cases. Here you have a mesh, a 3D mesh, and the idea is that this mesh can be used afterwards in any afterwards, meaning that the data was optimized. This is a SaaS solution where you can see the data inside, and then we can switch to another solution where you can do compare point cloud with design. And in this case, we are going to see how data over time has a predictability. Meaning that if I need to construct something till here and I have the design with this specific date, when I'm acquiring data in the point cloud, and if I compare the design with the point cloud, I'm really here or not? What is the prediction? Another design versus point cloud. This is a tunnel in the Alps, and this is the design part. We had all this data from different users that are highly experts. And inside this point cloud, you will see later on that this comparison with the design is going to be made by highlighting it with different colors. So green and red, you can put a legend and a scale in order to see how you're going to interpret those results. This is something a user works, a large governmental user from the States work on it. These are clearances from bridges. But what is very important is not that we are able to calculate those clearances, is that they have more than 2,000 bridges that they need to compute this clearance. So it's the span here from the water till the lowest point of the bridge. As you can see here, it's very important. And this was called data. They were having data on hardware. And we needed to do this as a digital twin and imagine all the workload that we have deployed for this. The idea was the following, that we have just captured where the bridges are, and we have from the point out that they were terabytes of data. We did not upload those data into the cloud in the digital twin because it was enormous work. We just took an envelope of the points that they were there for the point out for the bridges, and then computed only bridges clearances. We did not upload all the point out, or we did not process all the point out because it was not needed. So tricks like this, there are examples what to do in a digital twin and how to do them. This is a tunnel that had a classification. And this is important because certain elements, they were unknown, and it was, because it is with a huge traffic, it was very important to know how many elements there are there, different objects, ventilations and so on, and firefighters and so on. So the idea is that we need to count them to have a database and to know when to change them. This is a digital twin because we have a solution. The data stays in a storage that is widely used, that you have a SaaS page, a SaaS environment, where you can see your data. You have a digital construction, you can annotate. There are a lot of users that they can annotate inside. This is the phase of design, and then we are going to pass on the phase of layout data. This is a solution that is based on the latest technology that is called Cesium technology, which is a very fast rendering layer based on OGC 3D types. So this goes on, that you can annotate inside. This is another example of, we are going to have a mesh here on the left-hand side, and here we are going to have the Gaussian plats. You can use this QR code even now in order to go live, and you will see the same as I am showing here. So the main idea will be that the mesh that was generated using one of our softwares, it doesn't have a huge level of detail related to the electric parts here, the electric platform. But if we are looking on the right hand, so this is the mesh on the right hand side. On the left hand side, we have the Gaussian plats. And using the Gaussian plats, which is the latest technology that we are working on, and even in the part is quite famous, we are going to render starting with points and certain geometry with volume, those thin elements that they cannot be addressed with the old traditional way of a mesh. So in general, for visualization, we have better rendering here for the Gaussian flat, tower, control towers, and so on that can be used. In this case, we have real data. Again, you can use the QR code and you can go there and you can see the bridge. This is a bridge in the Netherlands. And the most important thing that they wanted to see, there are the protection spots here. You see here it's not very well seen, but if I go to the next slide, and if I use the Gaussian splats, you will see here things that they were not really before there using the Gaussian splats, and now they are here. So the latest technology that is from this latest month in January, we can see those parts here. And I'm going to end my presentation saying that there is a nice use case in Pau, in France, where the city hall decided to have a high precision digital twin to support the 10-year transformation plan and simulation. And this is very important because there is a unity part and we have put real models inside. And I'm going to let you see this video that's quite nice. Thank you very much. And I'm going to push this.
Yes, so thank you again for the presentation. We are a bit late, but if you have time for maybe one quick or two quick questions, maybe, please feel free to ask.
Thanks a lot for the presentation, very interesting. But to in detail, from the point cloud, is the identification of the elements, is it called semantic identification, that is
Yes.
to identify whether for the tunnel, whether there are some signs or road marking, etc. Or the 3D rendering, is it made automatically, or does it need some manual identification by the guys looking at the point cloud and stating, okay, this is the setback ready of the region, or anything else?
This is a very good question, so I will explain very fast the process in general. So first you need to understand your data. Let's say I have 100 kilometers of a tunnel, yes, and I would like to detect different elements. First, I need to choose the most representative objects, let's say ventilations. I will choose, let's say I have 1000 ventilation in total. I don't know exactly now, I need to detect them, yes, I suppose I have. So I'm going to detect, let's say, from this 100 kilometers, 10 kilometers of data. I'm going to digitize them manually, and I'm going to choose best ones that are really representative for this tunnel. And this is what we are calling labeling the data. So physically, I'm going to choose points inside the point clouds or images inside plan images or just zero images or both together. It is possible if they are overlapping 100%. I can use both. In some cases related to the geometry, we are sticking only to point cloud or we are sticking only to images. So it depends a lot how the model is going to react. So, or all of them, point clouds, images, or point cloud or images, it depends. Then we are feeding the model. The model lasts the process in order to create this AI detector. It depends on your data. It can last 1 hour, 2 hours, 3 hours, 1 day. It depends. And then you have an AI detector. The detector is just a bunch of files that is just defining what you are going to look at into the data for. So let's say that you have 100 kilometers and you use manual for 10. Then I'm going to use the other 90 kilometers to put this AI detector to work for me. And then I'm going to see what are the results. And then at the end, I'm going to check what is the asset inventory, meaning that I need to validate my model. And in order to validate my model, I will just pick a random area, and I will pick, let's say, 20 or 30 elements, it depends on my model. And then I will say, okay, this element, I know it is what it is, a ventilation, and the detector detected it as a ventilation. So this is how we are also validating the model. So this is all the workflow. And I was saying before that we have users having till 90-95% accuracy of the AI detection. So you still need to have this asset inventory manual at the end.
Thank you. Thank you guys. Thank you again, Hera. We need to of course, if you have more question, the coffee break at 11 will be not 11, because later we need you for that. Let's jump to let's travel to Pays-de-la. Nice country in France, thanks to Thibaut. So let me just this is it, yes. So this is the remote. You can have the microphone. So thanks Thibaut. So Thibaut, you're a civil engineer and an architect with 15 years of experience in BIM and digital technologies applied to the construction sector. So at CSTV, but we to CSTV, he had leadership and research responsibilities in modeling, concurrent engineering and life-cycle data continuity, supporting public and private stakeholders in the digital twins, from design through operation. You are actually involved in training and knowledge dissemination on digital twin in BIM, contributing to the digital transformation of the construction sector in France. And you are also a learner of the executive master because you are following a few courses of the master with the cohort. Thank you Thibaut again, and the floor is yours.
Thank you very much. I'm pleased there because, yes, it's my first time because the balls, I'm here. And yes, I will explain you how experience is digital twin. So that it's like 2 years now that we are working with regional Pays-de-la, which is a local authority south of West France. And since 2 years, we are building to implement these digital twins. I will show you because these are very different topics with different use cases. And today I wanted just to explain what we did, what we achieved there. And we are working on our first issue, our problematic that we have. And my personal focus is really not about digital technologies actually, it's more like how people are embracing those technologies. Because as you said, like a lot of experience with AI, with a lot of experience with city information model as well. What I saw is always the same problem that we have technology as well, but then how it works at the end with the end user. This is really something that I want to share to you how with the relational work we
C'est le dans le sens là?
Non. Ah, sorry. Thank you. Yeah, this is a week to go shopping because we did just before work, and I know that it's not easy to go afterwards. We will have time to talk together. We'll be there to talk to you. But the CCD is a big public company, and we have just this is part of the legacy, and we have different topics there. I am a researcher, I work for research and expertise. I have a division here that is working for digital technologies. And, but we are more in France known for evaluation, certification, it's about materials, about equipment and so on. And we work as well with knowledge dissemination, that's regulatory as well. And just it's not to make only knowledge for us, it's to share knowledge with students and so on. Yes, this is research at CSTV, just very quickly. We work on the different space of the CSTV, which is Center for Construction Center for Building at the end, but we cannot see buildings without seeing the cities. As I talked, we work with the three scales at CSTV. We work with sustainable cities. What we are working for the European Area. Then we work for building, responsible buildings, and then we work for continents, as we are testing continents with certification and so on. And that's the system of research. And then we have 4 domains of research. CSTV as there. So the first one is how we can live better together, very simple. But it's a lot for well-being for us, everything. Then we have the climate change, just a very big issue today that we work from research CSTV. So the third one is more something working out for many years. It's about the innovation and reliability in building construction, which is something that is very important as well. And we work with renovation is very important today. And the fourth one, research domain is the circular economy and the resource, which is today in time that is really important. Yeah, this is our research domain, just because you will see in our presentation that we connected all this research domain that we have there. Yes, and then digital, and part of the digital department is today. And we have 3 key domains. The first one is digital, that's very fast. The second one is artificial intelligence. And the third one is expert data. This is where we are focusing on CSTV because we are not really experts for artificial intelligence. It's not our first application for the state. We are more like an expert in the data. You can say that this is the right data, this is the right way to look at the regulation and so on. And for that we work with local authorities, today it's about our region we work as well with facility manager, and we work with, we have industry plan as well. This is the way we try to implement digital twin in our country. Our claim is you not digital twin, but it's not to explain where we are. So we have always a digital object, and we have always a digital system on the other side. And what we are doing with the region Pillar, where you see the red cross there, the problem for us first is to put the sensor on the real world. And something it's not that easy actually, because we have a lot of big data, but we don't primary, and it's not that easy. And then we have the data come to decision support. This is digital twin. Then we will see we have many predicting model and so on. But the main thing is to come back to the real world and to change something. Because when you are just in the digital system, like in the digital shadow, and it's now called virtual thing. And really, what we try to do with the Jupyter Graph is to be back to the physical object and to change really the real world what the end users are facing. So we have 4, we are actually 5. I just do it before. We have shown you 4 case studies that we have with the Jupyter Graph. So the first one is the repair quality. So we put a lot of sensors in high school, and with that we are allowed to monitor the air quality in the different schools, like more than 100 of high school, and this is a test in one of them, and then we try to make it for all of the high schools, which is an implementation question. This is the first one. Then we have the demonstration about the flood coastal. You will see it, we are in the south of France, close to the sea, and we have a problem there, this flood management, and we put there 100 sensors. And we were in the way you do it is the port management. There are many ports on the coast, and we work with the port of Nantes. There we have a lot of energy consumption in such port, we're just doing the same, and we try to monitor the energy with the digital twin. And the last one, which is really interesting as well, this is a public lighting. So the region is responsible for public lighting as well, and then we put digital twin for that. So that makes sense. So I'm sorry, I will not talk about everything, but it's I will give you just a couple of examples quite quickly, but it's just a way to show you how we are implementing it into the real world. This is important because this is an infrastructure of digital twin. What is our first issue was to develop so many digital twin in the region. And to get the same infrastructure is very important. Here we get the most of the thing that is how time we have the physical project, and then how we can control the data infrastructure. This is the first thing. So we have a partner, which is Joe, and we have a lot of BIM model, which is good, and a lot of GIS model. We bring everything together to make this data model of the city. And this is one part. The second part is the data storing. So we have another part of that, which is CS. And there we have a lot of IoT, and IoT is coming from the data storage to the data storage. It is that is ours, because we are more in the construction field, and we try to make this the business application. So we developed the AI model to analyze what we can implement then for the territory. So this is the table that you have on the left. The right side. This is the planning scenarios. You will see that just afterwards. Alarms for the security people. We have the facility management integration for the high school, and 3D visualization. Actually, it's very important as well. Yeah, and the last part on the side, it's GIS, which is the secure network for the whole region. And this is very important part as well, to make sure we have the right connection, not the software, not just going to the wire. This is inversion. Then we go to the demonstrator. I'll just take the data and that's okay to take. Well, the first one. So we go to the fourth. The first one is the digital twin for air quality management. Just show you because I have years from that to get this here. What you see here, this is the GIS model plus the BIM model. Everything comes together in our platform, and the platform of the region. And you can get just building and select different sensors. So we have plenty of sensors, things like static sensors here. And then trigger sensors, and we have all the data for the air quality, it's for hours, in a day, in a year, and you can see where the level of air quality is not good. In France, we have a regulation to that. You cannot go over 900 parts per minute of air pollution. And this is what we are just targeting here there with the digital twin. So this is the digital twin part is there, so it's monitoring the exceeding of quality of carbon. And then what we've done is to come up to the reality. This is, as I said, it's the most important thing for us. And we try to give to the maintenance teams of the high school what they have to do, where they have to work to get a better quality. This is really what we try. So it's quite simple, the idea there. It was not hard to implement. So, yes, I will give you just a few.
Come here.
I can. Thank you. And then we come back for the next video. Okay, so just a few things that are important from our point of view. The first thing is that technical prerequisites to manage to give the right alert. Well, this is the same, this is what is SMS, but the problem is that we have many of alerts. How they can manage all of these alerts? And this is really something that we have to configure actually. We are trying to say, no, this is not an alert, it's more than the regulation, that's true, but maybe not, and that's something that is really, really important. So we adjust per sensors the way we give these alerts today. The interoperability with the existing facility management is important because there this is only the digital alert. How we are going to come back to the abstract ventilation and everything system. Okay. This is something we are working today. Then we have a lot of organizational factors. This is really my concern today. How we, because people of maintenance actually they are not working on screen. They are just going to the different room, classroom, and just change the configuration of their ventilation. That's all. And then how we manage to make them involved in the digital treatment. This is something that we try and we are doing today. Yeah, and then our priority feature today is how we make this interoperability between the facility management system and the digital grid. This is the first thing. And then we try to make a better configuration of the system. Yeah, it's just not easy for you to understand that. Just very simply, we have like you say, the descriptive things on the left. That means that we can today have the air quality analysis, data analysis for 1 year. And with that, you can see where the air quality is getting very often poor on that. And this is really what we are doing. And so we have during the year, during the day as well. And now what this is data analysis, and then we are giving all this data to the AI to make this is what you see down there. It is to know where we are used to get higher level of poor level of air quality. And this is really what we are trying to do. And because actually, when you get in the morning, for example, you get really quick to the high levels. That is normal, actually. And when you are in the winter on south, this is different way. It's not the same level that we are expecting, actually. And with the AI, we can make sure we are evaluating the right abnormal condition. This is really and it's really interesting because first we are saying just yes, 900 ppm, this is right, actually not. And how can we say this is 1000, maybe one time it's 1000, but it's abnormal. And sometimes it's 100 ppm and it's actually normal. And this is really, with AI that we can do that. Okay, sorry, because this is what called the map highlights where it's normal to have the high level condition, level quality on that. And then every day you can be the right habit. This is what we are doing. So it's not easy to explain. I go maybe a bit quicker because cafe are really I know that you're waiting for that. So the next one is about the coastal fluid. I will be back to the videos. I was thinking very to show you this video because it's more explosive. This is exactly the same. It's the same we are always implementing the same solutions. And you can see the GIS, you can see the building model with a lot of information in it that are coming from the BDB, the French data for housing that we are putting in the city. For example, we can give the door height and the use case model there. So we can see videos, but here click on the sensor. And we have what to do the sensor on the bridge, just to know what is the water level of the bridge. And with this water levels, this is our idea. We are connecting to the closest scenarios of flooding. This is how we work. And now, as we say, in the sensors of the bridge, we see 1 meter, 1 meter 3, and it's close to this scenarios of the flooding. And this flooding, in this scenario, flooding is giving us the house, the buildings where we have the maximal problem, where the most of the issue. And this is our approach. And then with that, the security services in France are connecting today to the digital twin to know where they have to work first, to help the people and to protect anywhere. And then we have many different protecting scenarios we are bringing into the digital twin as well. Yeah, this is we have always the same speeches, just on the left. Yeah, so the idea is to reduce the damages caused by the flooding, because we know where it will be the most damages, and we can just adjust the security services for that. Technical issue that we have is that we got there very many data sources for that, more than the others. We have GIS, we have the weather condition, we have the beam, we have everything. It's not easy to manage. The second one is that we try to add. So I talked about protecting things and protect things against these floodings, and we try to make it dynamic. That means that we can just show the reminder. If we put just a wall there to protect, what will be the consequence of this? This is something that we try to add. It's not easy because we have to work with 3D to draw all the digital twin, which is not done for that. Yes, then for the organization, we try to, because here we have only the way flooding is managed for the sea, on the sea side. But actually, it's connected to the countryside as well. For example, for the sluice that we have from countryside, and we need to get data from that and read it. It's not easy to connect all the local authority with the countryside. But I think just 2 minutes. No, so next one bigger. So yes, it's this thing. So we give to the AI, to the extracted all the data that we have since 1 year of the water level. What we try to do right now is to connect the data that we have from the weather condition, from the wind, the speed of the sea, and to know how it can predict the water level of the bridge. And as I showed you just before, then we have the scenarios that is really appropriate and connected to that. And then we try with linear regression model. It's not very good right now because it's too much connected to the type 8, which is normal. But I think we will find the data that are more relevant for the area. Yeah, I will go quickly because I think you understand what I wanted to say. We work with energy consumption as well. So we're going to say that we put an energy sensor in the port. It wasn't really not easy. They took like 1 year just to get connected to the electrician and to make sure they put the right sensor wherever we wanted to have. And yeah, it was we were lucky, and just like 2-3 months ago, we got the data. Sorry. The problem is really important to system to connect, to have the right responsibility. We don't have any data manager in port. We don't have really people that are responsible for energy. And how do we do it? That's good to have to do it, but at the end, if you don't have any people to get involved for decision on everything, it's not easy. So we have to work on the management, the connection between the digital results and the responsibility that we have in the local authority, which is not easy. So yeah, to give all the data to the twin thing. The idea is to predict the energy consumption. This is the first thing, which is quite easy. Actually, it's linear regression regarding the temperature, but it's okay for winter, but not for summer. For summer, we are more like in another algorithm, like it's pretty fast that we are using that. And with that, we have schedules, 24 hours schedules of energy. And when you have the energy which is more than what is predicted there, this is abnormal. And same with the high school, we go back to the maintenance to say, yes, there is a problem with energy consumption. Why? And what do we do? Yes, and finish with two techniques. I thought we worked in Miami, but it's a sort of racing point. And then we just sorry. Do you have the video because it's better? Just because there is simulation and physical model is really important for us. For that. Yeah, we got the different landing points. We have thousands of landing points, but we just make a test for place and street there, and we take all the features, the landing features, which is not easy. The problem of data there, because every industry makes different formats, and it's to learn really together, but it's not easy. And here, what we do is that there was stable simulation, we are good for that today, but then we have to talk with Major, and with public authorities, and they wanted to see really what, so we have different scenarios of that are simulated, we are changing the power of the lighting and everything, and how you can feel it when you are on the street. And this is what we very much on to manage. So, yeah, at the end, this is security, this is comfort, and what we wanted to work on as well, this is it's the energy. So we connected the digital twin to the cabinet of Linux, where we got all the consumption information, and I will show you this afterwards. But this is what we try to do. Yes, yeah, I would say the problem here was that it was only for Linux, and only for Linux, people don't want to pay for digital. That's it. And really, what is really important for us, for the local authorities, to make the teacher to connect to all the use cases. Otherwise, it cannot work. And actually, because it's the same fashion for all digital twin there, it's used, it works to pay for it. And this is really what we have. But then we make all data on in the digital twin, and which is really interesting about thousands of data, and just to give it to at the same like the results to know where we have a problem and where not. And so we have to analyze it, it's complicated as well. But when you give it to the AI is just showing to us really quickly. So yeah, you see it in red. This is where there is abnormal consumption in the Linux systems. So actually, there was not only 3 or thousands of Planningacross. But it was quite interesting. You don't need those strong data analysis, just the digital CU. This is 0798, where we have abnormal consumption, and then back to the 38, to the digital twin, say, here is the issue that we have in the chapter. This is it. I give you just my conclusion to that. The first thing is we engage as a public authorities. We are lucky because our politics are with us. And it's our Constance Mula, the president, the vice president of the she's the president of the region, and that means she is really with us, with the data and everything, so that's very well. And we have a Géo Total program, this is a digital program for the region, and then we have many, it was easy to work actually, when they are really with us. That's okay, but then the problem was to go back to the local, not the region, but the local authorities. I mean, the maintenance teams of the list of the high school, that's the visit, the electrician of the port, as I said, and for each demonstrator there was a lot of human issues, and that was our deal. And, as I said to you just before, we had actually the last organizing all the meetings together, we were 100 together to talk about that. That means we have a lot of people involved in the territory to achieve that, and for me it's the best achievement that we have before technical and everything. Yes, and the next step, what is the next step for us? So everything not really standardized today. It's more like we make things goes together, but we have a huge work on the standardization of the system, on the ontology of the data and everything. And this was not my first focus, as I said, it was more the human interaction. But now this is really the work that we are crossing right now for the next year, everybody. So this is it.
Yeah, so thank you, Thibaut. So we are quite late. But if you have one question and the rest for the coffee break, we can hit as you want, or we can discuss directly to the coffee break if people need the coffee. Thanks again.
I need as well.
Yeah. Thanks again, and we have coffee break, and we come back at noon, let's say. Okay, and thank you. See you in a few minutes.
Everything is inside.
This is okay. Yeah, perfect. And that's
This was included.
yes, it was
these are
yeah,
just-
that's for the end. And do we need to say something?
Yes, we also have these things that I don't know who needs to sign it.
Okay, what is
We
it?
theoretically the stamp from the university, and I think you can also sign, but the stamp I think is necessary from the institution.
Oh, it is for Erasmus for the travel.
Yes.
Yes, so I am not allowed to sign this thing. We have to ask Mark-Christine, and she will be at the dinner tonight.
Okay. So we should bring it to
Yeah,
the dinner.
yeah, because last time my son was kind of thing, she told me I shouldn't have.
It happened with Tamás, no?
So yeah, so
Because she also signed the contract for the invite letter for this, so probably she needs to sign.
so yeah, bring that tonight to the restaurant,
Okay.
and don't forget, and we will give, we will ask her just to send the fee. And she can do it tomorrow. But don't forget, because I will forget.
I would not. Okay, so I give you all the
Perfect.
documents.
Yeah,
and
I need to give them too, but I will give it after that. Okay, thank you. Salut Narline, ouf, je t'ai vu de loin, je t'ai même pas dit bonjour.
Un étudiant trop jeune pour nous, dans la cible, il est venu écouter la conférence. Non, prépa. Deuxième année de prépa, il va faire des... Et ce que je lui ai demandé, c'est ChatGPT, il est intéressé par les jumeaux numériques. Il veut faire informatique. Et donc, il a demandé à ChatGPT quels sont les événements liés à jumeaux numériques. Je te jure. Alors que les élèves d'école des fonds, ils ont cours sûrement.
Bah oui.
Non, mais c'est trop bien. C'est bien d'avoir des limités. Ah ouais. Je dis que c'est trop bien. Est-ce que je peux t'aider à quelque chose?
Non, je prends un café.
Voilà, ouais, je prends bien aussi. Ouais.
Non, c'est bon, marché fonctionne, je pense.
Je te rejoins là-haut, je vais prendre mon téléphone.
Vas-y.
J'envoie un mail, Est-ce que tu as la date d'ouverture des candidatures?
Si seulement.
Ouais, parce que j'ai un profil intéressé dans le CRM, je voulais lui dire. L'année dernière, c'était le 17 mars. Non. On est en février.
Non mais attends, mais c'est pas ça.
Oui, je sais. Non, 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 je sais que. Ouais. Bon, ça veut dire que j'ai fait.
Après, je peux le temps là-dessus.
Y que solucionado. Ya, pero... Mira, ya vale mucho que no había visto que había cafés que no había dicho que ¿sabes lo que pasa? Que cuando yo, o sea, cuando yo ya delego, o sea, lo olvido, es como que esto está, y ahora entiendo mi contenido está hecho, me olvido. Porque si yo no me olvido, ayer antes de ayer se me viene esta vez, porque me ha montado. Y bueno, yo no sé. A ver, primero que yo comprobar. Vale, aquí hay un solución de que creía y hay varios sistemas de creado en una serie. Ese es el yo lo vi en que se tiene una sala. Vamos a ver
Réunion collective en marche. Ok.
Je suis là.
Ah, bonjour Rémi, tu m'entends?
Oui, ouais.
Super, merci, désolé, on est vraiment à la bourre. Hein.
J'ai vu ça.
C'est toujours compliqué
C'est Thibaut, il est trop bavard.
on va commencer là. Je suis en train de récupérer. Je vais je peux faire ça. Alors. Est-ce que tu peux essayer de partager ton écran pour voir, s'il te plaît? Je t'ai envoyé mon SMS. Je t'ai envoyé des SMS.
Tu m'as envoyé quoi? Ah, attends. Ouais. Ok. Effectivement, c'est désactivé. Pour partager ton écran, il faut aller dans la liste des participants. Et... Attends. Plus. Il y a un bouton demander à être hôte. Attends, parce que je suis sur le mode web, donc il faut peut-être que je ressorte et que je passe sur l'application.
Alors, oui, moi je suis sur l'application.
Ok, moi je sors, je reviens, j'arrive.
It's just for you.
Ok, est-ce que tu m'entends toujours?
Bon, ça marche très bien.
Hello, Mathieu. This is Abbas.
Hello, Abbas.
How are
Demandez
you?
votre.
I'm fine. It's very nice to hear your voice, Abbas.
Yeah, the voice a bit is weak, actually.
Yeah,
And
yeah. And now it's better, I guess, no?
yeah. But when the lecturers are talking, actually, they're speaking. I mean that the tunes comes with. I mean that the tones comes with echo. Actually,
Oh,
sometimes it's not too much, but it affects.
okay. We try to optimize the setup, but it's a complicated system. I'm not.
Yeah, sure. But thank you very much for I mean just establishing the online.
No worries, no worries.
Thank you
And
very
we
much
are,
for it.
and thank you to join, and we are pleased to hear
Yeah,
your voice and
yeah.
to see you online connected.
Yeah, actually, it was very bad for me to not participating in this seminar because exactly it's related to urban planning. That's my profession. So, yeah, I really miss this conference and atmosphere.
I know it's a pity. We are really sorry about what is happening.
Uh,
But
you know, actually, the things are calmer now, but you know that they still have problem with.
okay,
There's some conflicts, actually, political conflicts that's unresolved. People just waiting to see what
yeah.
happens next. Yep.
But be reassured, we will do as much as we can to assist you for the
Thank you very much for
continuity
your. It was
for the
great.
master, of course.
Yeah. It was great to receive very warm responses from you guys. Thank you very much for it.
No, you're welcome. It's normal.
Yeah,
And thank
thank
you
you.
for sticking up with us.
Yep.
So
No, I really am committed to the program and the great contribution to it from my side, actually.
okay, that's good to hear.
Yeah. Thank you very much.
You're
By the way,
welcome.
we
I
are
think,
here.
Rémi,
Yeah.
ouais, ça marche, hein, je pense que tout va bien.
Everything is fine on my side.
Okay, so I will just gather people.
Yep.
That's the idea. And we have Get up. Can you check? It's working? Zoom. Remy, can you still hear me?
Yeah, everything's
Perfect.
fine on my
Okay,
side.
we will start in a sec.
Okay.
So we are going to start again. Please join the seats in the room. So we have with us today Rémi Montorio. Rémi is head of cartography and geospatial analysis at the European metropolis of Lille in North France. He leads the issues related to digital twins of territories for the local authority. Since years, Rémi is involved in implementing digital networks and tools capable of responding to urban development and infrastructure challenges, mobility, environment, living conditions, urban planning, energy renovation, etc. In recent years, he has also been involved in R&D work related to AI, BIM, territorial indicators. He is also a member of the 2050 board and part of the pilot team for the local digital twin working group at the national level with French geospatial data council, CNH. And he used to be a teacher also in the executive master 2 years ago. So let's travel to North of France now and to continue our journey. Thanks for me, thank you for joining us, and the floor is yours now. Thank you.
Thank you all, and thank you, Mathieu, for this event, and I will try to keep on time and to present our subject in Lille. Just a few words on Lille, because many of you, I think, don't know much about this city out of LOSC team for football. So it's a pretty urban territory with 95 municipalities. So we are a local government with a number of municipalities with 1.2 million inhabitants. And the main challenges for us is that we have major infrastructures to maintain, a very deep challenges regarding urbanization with old industries estates to refurbish, to transform in new capacities to limit city sprawling and to ensure a better environment for our citizens. Today I will speak about digital twin for sure, but about digital twin on one main subject, mobility, and also with the link on land development, and also speak of another initiative ongoing on our side. Since 2 years, 3 years now, we develop a digital twin strategy based on an initiative of our president and a vision. Our president wanted to enhance our decision-making capacities linked with this kind of technology to ensure and to promote also data quality and to promote the use of our data coming from internal production, but also produced at a national level and produced by our third parties like transportation authorities or land development promoters. The main idea in French is to scénarize the tomorrow territories, and the real idea is to be able to give a vision of Lille metropolis territory by 2030, 2035, 2050, and to be able to follow and to have a clear vision of what our territory will look like in few years. Our actual trajectory track for developing this digital twin. Nowadays, we have what I will call a static digital twin. We have a 3D mesh, we have a lot of open data, and we have public access and interfaces for this digital twin, but it's not a real digital twin as you may know now, part of your course, part of the master. And we want to implement and to move forward a better experience and enriched experience around data with more connectivity, with more dynamic approach and tool, and more interactivity at the end of the journey. The main topic we are tracing are the urban planning with a project called Space Up. I will show you few items on this subject later on. Climate, mobility, facilities management, and security with urban supervision. Yeah, very few ideas. I will not go deeper on this subject, but on our overall vision of the urban digital twin is really based on what we are doing for years on data. Data governance, data platform, data availabilities are the key inputs to enable further on digital twin approach. And we start, in fact, our definition of the digital twin by the capacity to have advanced analysis and to deep dive in data, and to have a user-centric approach based on indicators and use cases. So just to position our definition, let's say. Nowadays, our advancement regarding technical aspects, we have already all the, as I said, the reference data, the mesh, the 3D mesh, the static data to enable to have a full 3D digital twin of our territory. What we still have to develop is really the IoT and the sensors part and the sensor strategy. We have some sensors that I will show some example of their use just after. And then the other aspect we are developing is the simulation capacity. And again, regarding the example on mobility and land development, I will show you some example on these two aspects. So first use case. So this use case was developed part of in the context of a partnership with Aegis company and another academic partner, which is ESTP, to develop digital twin for mobility, but not mobility as a forecasting approach of what will be the mobility behaviors, but how, in fact, events and predictable events on the territory, like walks, like big events, football matches, or main animation on a local level, can affect transportation, and how to scenarize this mobility and this traffic management in these circumstances. So we set up this project with Aegis. We gathered some motivated and committed actors, internal actors, but actors which are directly concerned by really operational challenges on this subject, to define a project and a use for this digital twin. So we started our journey early 2025, and we just, in fact, finalized this first step of the project in November. So to clarify the user story and the use case, the real idea is as a mobility engineer or on-site works manager, you or I want to simulate the traffic variation generated by the closure or the modification of a street traffic management in order to communicate the inconveniences caused and to select, in fact, the best scenario. So for this use case, we mobilize sensor measurement, we mobilize consumption site requests. We have also as a means a deep traffic model at a city scale called M. And we wanted at the end to measure the impact on mobility. To have also a field to try and to evaluate this project. In fact, we have a very important infrastructure project actually ongoing in Lille Metropolis. It's the construction of 2 tramway lines and 2 high-level service buses infrastructures. And we selected 1 tramway line to identify how, in fact, we can optimize the management of this tramway development regarding the impact on local traffic. So the main, in fact, challenges and obstacle we identified on this project is first reactivity. In fact, to be able to mobilize a traffic model with a short-term project with very accessible, let's say, capacities to evaluate the impact. 2, problem of granularity. In fact, if you are, I don't know how involved you are regarding traffic management issues, but often traffic models are very at a city scale with only major roads modelized. So here the main challenge is to modelize every road at the demand, I will say, depending on the scenario we want to try. And the last is the update. In fact, I don't know if you know, but regarding traffic management, all these models are based on surveys, and these surveys are very, very expensive ones, very important one to be conducted. So, for example, the last survey available on Lille Metropolis territory is from 2016. There are some major change in, for example, in works organization since that time. So it has a strong impact on how we predict, in fact, the traffic at a local and or regional level. So the idea of this digital twin approach for this project, see that some text is not translated, is really to shift, in fact, from a traditional, what we say, a 4-step approach, which ensure, in fact, to have this overall vision of traffic prediction at a regional level, to move to a very local level, to stick with reality and to shorten decision making at a local level. So it's really a complementary approach to what you may know regarding traffic simulation at a regional or city level, I would say. The approach, we'll say the UX and UI approach we have on this project is really to discuss with a team of practitioners and to ensure to better understand their need, and then to very converge and to target, in fact, their precise expectation regarding the tool. So that's a key thing thing I think when speaking of a digital twin approach is also to take into account the final user and to make sure that what you develop is not really already existing, or to miss the target of what the final user expect. Yeah, maybe I will just move forward. Yeah, overall idea regarding the minimum viable product is really to have to be able to address the persona story of a road work manager, and to simulate a road closure or road modification, and to be able, based on key indicators, to discuss with local stakeholders like mayors, like traffic managers, to enable this discussion, and then to implement some scenario regarding traffic management. So what it looks like at this stage is really, in fact, few steps regarding an application set up by Aegis, which allow, in fact, to create, to select an intervention area, to create, in fact, and to simulate the road closure, and then to measure this impact. So few screens to show what it looks like, and the idea is really to have a very simple final product, we'll say, for the user, even if the methodology behind, I will show you just after, it's pretty complex regarding the fine-tuning of regional simulation to a very local level. So the overall idea, in fact, is not to simulate all the impacts of a road closure, but very to select a very precise area and to measure local impacts, expected impact at a local level, and to be able to compare different scenarios and possible impact regarding traffic reported to other, let's say, streets situated just beside the closed street. So to predict this traffic, we had to mobilize sensors data and really to conduct what is called a traffic flow reconstruction, to have a local traffic density modeling based on real-time data and based on these sensors. So we, in fact, take touch with other projects, other cities like Firenze, which develop a project called Snap for City, and we already experiment, in fact, this subject on their territory. The overall idea, in fact, is to take the overall model and to fine-tune the model with very local data. The main challenges we have on this project is that we were not able to have as much sensors that Florence had, that Firenze had. So we had to measure and to iterate more and to confirm by on-site surveys that the model was properly set. So we are, just to give you an example, we mobilized and this example 53 existing sensors which are on terrain, and knowing that we have a bit more. We kept only 43 sensors because of some sensors out of service, and that we wanted also to keep a few sensors as verification sensors for our studies. Yeah, we prepared the data, etc. We've moved fast on this one, and then the density propagation. Just to explain how it works, is that you initiate, in fact, your model based on the capacity of each section. So you consider like traffic flow spreading in each city based on its, let's say, diameter and capacity. And at the end, in fact, the model based on your sensors will mitigate, in fact, the traffic in each city, depending on the sensors. So statistically, it gives another idea of the impact and the predictable traffic at a time on your territory. And then, in fact, the overall simulation challenge is to be able to modify one node, one segment of this model, and to measure, in fact, the impact. So you have the vision of before closure, and then we'll modify one particular segment, and the other if segment will be affected by the traffic. My last element on this use case, in fact, the final status of the work, the main challenge, and this subject still ongoing, is really to identify the key indicator for the final user and for the discussion with the stakeholders. Because depending on who you are speaking to, you will not be expect, in fact, the same indicator. For example, for some, they want to know how much traffic will be moved to a neighbor road. In some other cases, you wanted to know, in fact, the amount of time you will spend in traffic jams based on this obstacle. And even for the local authority, the decision should be based also on the duration of the work, the traffic impacted, and maybe the time spent. And you may want a composite indicator. So we are still defining right now what is the key indicators to be set up to be able to have this kind of information. And then last step, we are investigating also the possibility to have feedback to the actual users, actual, in fact, drivers in the cities, and to give feedbacks on possible impact of the different works ongoing. Just to give you a slight view of the other subject we are developing regarding digital twin, the main other subject ongoing on urban sprawl management, so very different subject. The idea on this one is really to be able to go from a land unit to a territory level and to identify vacant and underoccupied properties, to be able to mobilize this land to densify, in fact, the city and to limit sprawl management, or to buy these lands to be able to construct public equipments like schools or sport facilities, etc., etc. So on this one, same approach, really based with local users and local practitioners. And here the main challenges are to mobilize very various inputs at a local level to find out good indicators and decision indicators regarding urban planning and this cartography of potential resources regarding land, and in fact to be able to motorize the land acquisition strategy of the metropolis with alert management and with really a strategy to set a good action on our territory. the overall idea of this project. I like this picture, this graphic is really to identify one stream of this traffic based on various criteria, which can be the use of the building, the time period of construction regarding quality. We have some quality labels in France, and to be able to select streams that are the streams that we want to investigate and to mobilize as part of our public action. As we are reaching the conclusion, it's just a summary of the result obtained on both this subject is really approaches based on use cases. In fact, we are developing an infrastructure for digital twin, but what allow us to move forward are these use cases and to identify the key indicators, the key needs of these users. Both solutions are set as demonstrators, allowing, in fact, to finely define key features, interfaces, and in fact to identify also need regarding the infrastructures we set. We have strong involvement on simulation capacities, and we want, in fact, to users to understand that they are key actors to enrich data, to put forward data for other users, and to be able to have a community of data producer in Metropolis. And all these subjects bring and allow to push forward technical specification at a local, but also shared with our national counterparts on digital twin. Other subjects we are investigating regarding technology is impervision, vicinity monitoring, simulation, crisis management, all to be able to tackle with the different use cases defined by our community. One final word, and then I will be open to question. On French community for local digital twin, as Mathieu said, I'm part of project Mind Association, and just underline this aspect because for us in France, that's one key aspect of this digital twin approach is that in fact we do not want to have twins for each, let's say, thematic, each territory, but really a network of twins able to talk together. And that's in this sense that these associations and the work going at a national level in France are pushing forward common standards, common approach, and common specification to set up digital twin at a local and national level. Hope I keep on track with the time schedule, and I'm open to all your questions.
Yeah, thank you, Randy. We have time for some questions, but I have only one, if I may, and to be a bit provocative. Sorry in advance, but you talk about traffic provision for drivers, basically in the area of Ville. And I just a question about, as a public authority, you want to provide this service, and how do you compete with Google Traffic or Waze? And I think it's a good way for governance and to say that we don't need Google anymore, maybe in Europe. But it's a bigger question, it's in Europe.
Yep.
And so that's why it's a bit provocative. So I'm very curious about your insights.
Yeah, no problem with this question. In fact, we really are in a partnership, for example, with Waze in France, and since that we provide, in fact, Waze with our schedules of works for incoming month. And in return, in fact, we share data with them with what we call virtual sensors regarding their data to have updates, to have alerts on what's going on our network in Lille Metropolis. So that's really how we work with them. And regarding our use case, we really see it as more predictive approach that Waze do not implement. In fact, Waze measure, for example, what's happening, but do not look forward the possible modification. So that's very complementary. And the other aspect is that we are mobilized also our sensors to measure and to fine-tune this simulation to have a really local and let's say agnostic vision of what's happening in our city, and not based on Google on Waste solution based on mobile information mainly.
Yeah, okay, thank you. Sorry for forgetting. Is there a last question before we move on? Feel free. Yeah, Christine.
Yes, hello, thank you, Christine from Eventbrite. I was interested in the first use case about the management of the events and the impact of mobility. Did you also involve other parties like the police or well, I don't know, in order for them to use this digital twin to be aware of what happens and to prevent, and maybe to plan also the positioning of police forces to encadre these events?
At this stage, no, mainly because, in fact, when we discuss about police issues regarding traffic management in cities, in this particular case, it's at the mayors who decide, in fact, of the implementation. But yes, I think regarding fire departments and police departments, that's key issues that the next steps of the project will have to address.
Okay, thank you again. So we have to last question, very short one.
Hi, thank you. Very quickly, thank you for the presentation. Do you research anything about emissions related with mobility?
Sorry, I have not.
CO emissions, contamination, pollution.
Emission of
Oh,
pollution.
okay. Sorry. Yeah. Yeah. Regarding gas and pollution. In fact, it has not been outlined as a key indicator in the measurement, but yeah, in fact, it can be one important aspect. One limit you have to know about our traffic model also is to take. We are not able at this stage to take into account the part of heavy traffic of trucks in traffic, knowing that. Trucks are the main polluters regarding gas production. So it's very complex indicator to manage. That's why we have not selected it for now part of this project.
Okay, thank you. We can thank you again. Thank you, Rémi.
Thank you all, and sorry not to be here today, but thank you for the questions.
You were with us. Your digital twin was with us. Thanks again. And now, so we have two more lectures, and we jump to R&D presentations. And as Christine said, we still need to do some research to develop and to improve all these new tools. So I welcome on stage Maxime Paulet. Let me just share the screen now. Yes, where is the remote? Yeah. And just adding my little sheet to it to be sorry, Maxime. So Maxime, so you're doing a PhD in civil engineering from the University of Bath, UK, and you are now a postdoctoral researcher working for the CNRS and Laboratoire Navier at École de Pont, so in this building. Your research focuses on applying machine learning methods to the construction sector, particularly for structural design and life cycle assessment. And the topic is about life cycle assessment from conceptual design to using generative deep learning. Thank you, Nancy.
Great. Thank you, Mathieu, for the introduction and for the invitation to this talk. So to position this talk with regard to the overall conference, in terms of scale, we're talking about the building level, and in terms of planning phase, we're talking about the design phase of buildings. And so my research, as the title suggests, has to do with life cycle assessment, conceptual buildings, and generative deep learning models. So, example. To give you some context about first life cycle assessment, LCA, some of you may know about it, but it's becoming increasingly standard for environmental performance assessment. It's been used a lot in industry, not only in the construction sector, but also for other products, all kinds of products, actually, maybe phones or laptops, anything. Some key features of these methods, as the name suggests, is that it has a life cycle scope. We take into account all phases of the product. So in the case of buildings, we're looking at the whole extraction of materials, transport, manufacture, the construction phase, the use phase of the building, and then the construction and waste disposal. Another key aspect is that it's multi-impact. We measure and calculate many environmental impacts, not only CO2. We can scale, we can calculate land use, but also electrification and many other applications like the formation of algaes, which may damage ecosystems. It's a comparative method. It only makes sense to use SCA when you're comparing two alternatives for a product. Finally, it's based on a functional unit, which means that when we're doing the comparison, we're actually comparing with regards to the common factor, which is how these two things we compare are being used. So, in the case of building, functional unit means something like one building designed according to standards for an lifespan of 50 years or something. So this plot shows how we actually go and we do it in LCA. We have the system of interest at the center of our building, and basically mapping every human activity that goes into making of such an asset. So in the case of a building, that may be concrete pollution, and then we look what we need to do to produce concrete, or we need to produce cement, we need to get water, extract sand, and so on. So we have the entire tree of all the human activities until we reach the biosphere, so exchanges with nature. So it's a great tool, and now it's mandatory in France for new builds with the early 2020 regulation, which started being used in 2022, I believe. And so this forces building designers to conduct an SCA about the building when they ask for the construction permit, and at the end, once the building is built. So it's something like actually, SCA is only being used in practice a posteriori after a building has already been designed. Whereas actually we like to use it as an actual decision tool when we're making buildings, when we're making decisions about the materials, or other kind of things. It's a typical problem in design processes where we have a lot of design freedom at the beginning, and then as we progress through design process. We need to make choices. We commit to certain choices, and it's quite hard economically to go back and change things. So actually, we can't really make choices, use SEA to we don't actually use SEA to make design choices. So the objective of my research is to actually enable the designers to advantage of SEA design. So how do we do this? Using a prompt that's called inverse design. Inverse design is about excuse me, not a bit here. So the traditional way to design a building is that we select design variables like the length of the building, the width, the material, then we build the model. At the end, only we are able to only at the end we are able to zero performance criteria like lifestyle impacts, costs, weight, this kind of things. So the idea of inverse design is to avoid this process and specify the performance criteria at the onset of the design process to generate directly design alternatives. How do we do this in practice? There are several ways, but the one I'm looking at is generative deep learning models. So these models have been used in the literature to generate design alternatives. Here you can see some work from a research group in Zurich, I think, where they use these models to generate these vertical building structures. So the design parameters they set are basically define the shape of these structures, and the performance attributes like the surface area, sun exposure, wind exposure, and so on. And so thanks to these models, we generated a big data set, and with this, we're able to specify as the input the performance attributes in the test, and directly generate shapes that satisfy these objectives. Here's another example where I did it for these pedestrian bridges with similar ideas, design parameters being like given heights, geometric or material descriptions of the bridges, and as a performance attributes, costs, weight, volume, and something like this. And so the key for research is to use a similar approach, but to use as performance attributes, not cost, weight, but actually SCA environmental impact, so that we're able to then to generate buildings that satisfy certain environmental impact thresholds. So now we go to a little case study that we did a few months ago, where we started generating a data set focusing on the housing buildings. So we generated about 80,000 buildings with various shapes, so we are like all the parameters that we took into account, including width, length, lots of other geometrical descriptors, number of floors, and then also different materials, timber, steel, concrete. And so for each geometry, we fully conducted structural design with like a database of calculated structural elements. So you can see what it looks like. And finally, once we have all the material quantities for each of the 80,000 buildings, we computed the LCA using some generic material production processes. So here you can see it looks like, for example, for 1 cubic meter of concrete. So you have some phase, as I was mentioning, we are taking into account to produce 1 cubic meter of concrete with activities related to production and construction, to the use phase, and then the end of life. So once we have our own big database with all different types of buildings, as well as environmental impacts, we're able to create and train a generative deep learning model, which does a display of conditioning now. I won't get into the details. Feel free to message me if you want to know more about the exact algorithm. But I try to explain instead of how it works, rather what it does. What else to understand is that there's two main parts. One part that is a separate encoder, which takes as input building structure and outputs some performance criteria. So in our case, SCA indicators as well as the geometry described as the surface of the building. And then there's the generator or decoder that takes these performance criteria as input and generates different building alternatives that match this condition. So all of this together may not seem very useful, but actually they're only together when we're doing the training phase. And then in the use phase, we're actually able to take these two models, separate them, and use them independently. So here is what the solving encoder can do independently. For a given building structure, it's able to calculate in milliseconds the performance criteria. In our case, the carbon, with an error of 2%. So it can be used to like scale structure that don't say from what to design the building. But the most common tool is the generator encoder, where I'm able to specify performance criteria, such as CO2, but also target surface, and directly go ahead and generate in a few seconds hundreds, thousands of building designs and satisfy these conditions. So here's an example of the structures generated using a target of 200 kilograms of CO2 per square meter, and a total flow area target of 2,000 square meters. This plot is a bit tough to look at first, please bear with me. It basically shows the performance of the generator for different types of targets. So on the horizontal axis, you have the target flow area going from 200 square meters to about 10,000. And then on the vertical axis, you have the environmental impact, the CO2 per square meter. A species of cell is basically a combination of these two targets that we use to generate the thousands building designs and measure how far away from the targets that we fed as input. And so what you can see is the error model makes on average for each target total. And so what happens clearly is that the model is quite good in the center of the data set. But when we run edge cases with like very low carbon or very high, but there's very few data points in the data set, it's quite bad. So this is actually ongoing research where we're trying to extend what we've done and take into account other environmental impacts, but they should be found into account the impacts for the structure, so to take into account impacts from the use phase when we actually live in the buildings and use the So we basically use the model in this framework to generate structures, then we generate walls, isolation, and conduct building energy simulation to get the final CA of the entire system. That's pretty much it. Some total actions that we have for our research is to improve the robustness of the CA by taking into account a higher number of indicators, increasing the representativity of the data set. Actually, as you've seen, the buildings were little bricks, periodic bricks, because we simulated the data set. So using real world data would improve the tool. Then improve the generative model, of course, and compare what we do with traditional optimization methods. Thank you for your attention, and please feel free to message me if you want some more information. If you have reference for thank you.
Thank you, Martin, for the presentation. Do we have any questions? Okay, I'm going to. Yeah, it's good for this export.
Thank you for the presentation. I was doing this. Just one question. Can you explain your table again? I feel like I missed.
Which table?
The big table with the two different axes. Can you explain this?
This one, yeah. Yeah, so
I feel like I just missed that part.
Il faut allumer peut-être. Il faut allumer peut-être. Il y a un curseur, ouais.
okay, good. Yeah, it basically shows for which targets the generative model is accurate. So like, I have two targets for this model. One is an environmental impact, so CO2 per square meter, and one is the total flow area. So we specify these two things when we generate a building. The horizontal axis is related to the total flow area target, and the vertical axis is related to the environmental impact. And so basically with this table I was trying to see in which cases the model is accurate, by how much, and so for which couple of targets.
So for instance, the first cell on the bottom left would be the model generated very few buildings that were around 200 square meter, and that were depleting the CO2 emissions.
Yeah, so basically if you take, let's say, the cell that is at the bottom left, I generated using the model 1,000 building designs, specifying as input target total flow area of 216 square meter and CO2 target of 52 kilograms of CO2 per square meter. And so this 226% is the error the model makes with regards to the CO2 target. So it's actually over 1,000 of building designs generated. It's at 226% error, which is not great. But that's the idea of these models, right? They're good in parts of the data set where there's lots of designs, there's lots of points in the data set, and they're able to map the relationship between environmental impacts and building designs much better. But at the edges, when we have low environmental impacts, for high environmental impact, there's so few points in the data set, and we're able to learn that part of the space.
Congratulations for the presentation again. I was wondering why the quantiles are divided. So if you check the 0%, from the 10% to the 0%, there's a lot more distribution. And also the upper bound from the 100% to the 90%, there's quite a lot. So there's a lot of uncertainty. I was wondering why you divide only in 10 quantiles instead of more, so that you could like analyze better where the uncertainties in your model are.
So actually, I did it like this because I was looking at the quantiles in the data set. So in the training data set, I took the maximum, minimum, and I put the quantiles in between, regarding the data. And so I did like this because there are so few points on the 50, on the lower bound, so few that I suspect there might be some outliers in there. So I didn't, like, for example, from memory, I think that from 100 to 52, there's only one point, which is at 52. So that's why these two also methods where I showed the normal scale, but then keep that.
So how many samples are there in total in the left axis? In the y-axis? Right?
You mean in the dataset?
Yeah, the dataset, how many samples?
So the training dataset had 92,000
samples. And you had only in the first quarter and the last quarter one data,
yeah,
one sample?
Yeah.
Or
I think it shows on the previous plots, maybe. I'm doing some prediction. Like you can see there. So this is only the test set, so not the data set. But well, you can see the test set, which is about 20% of the entire data set. There's not a single point below 100. And yeah, they're quite isolated basically.
thank you.
Good morning. Thank you so much for the presentation. I'm not an expert in building. I'm more focused on mobility, but I made some work on life cycle assessment on mobility services. And I was wondering what type of life cycle assessment database you use to model materials and building. This is because it is easy to solve here just that you make it easy, but the model and having all these databases and it's so complicated.
Yeah. So actually I'm a bit lucky because when I started, I took off from Pierre Durtin's thesis, where he did a full thesis about creating these models for different types of materials. So there's sort of average values for the French context, and all the models are open, so they're all linked to the eco-event database.
Thank you. And just thinking about more policy level, did you also study like a main recommendation on how to do buildings with low carbon emission? Like what are the key parameters you have to focus when you are deciding on these parameters? Because it could be interesting to have a guidelines on this.
Yeah, so basically that was also part of the work of Pierre and Roberta, was I was trying to look at different building designs and which parameters are the most influential. And so some of them are under structural world, the type of material you use for the structure is quite important. Also, how much your structural elements span. The longer the span, the more material you have to use. And then there's also a link to the number of flows. The higher the number of flows you have, the less impact you have per square meter, because the environmental impacts caused by the roof are sort of spread out, divided equally through the flows. So there are some parameters that you can get from a parametric study. Now the real plus from these models is that the model will also learn the interactions between these different parameters and how in some cases certain interaction may be more important, less important than others. That's less using this kind of tools.
Yeah, thank you. So we rush, but we are a bit late, and for more questions, because il y a the lunch effect. Again, merci. And to finish the morning, let me stop here. And we have Sebastian Atsoy. Hello, can you hear us?
Yes, I'm here and I can hear you.
Yes. Thank you for joining us and very sorry for the little day in the morning. Can you maybe share screen? Did you put the code to share the screen? I sent you.
Okay.
To try if this is working. Oh, yeah, I think it is working. Let me just. Yeah, everything is working. So, as now you're an architect and urban designer, specializing in the intersection of architecture and urban data. You work as a lecturer and researcher, and you're currently pursuing a PhD in architectural design computing at Istanbul Technical University in Turkey. And your doctoral work focuses on assessing the adaptive reuse potential of office buildings and shopping malls in Istanbul, using data-driven methods and urban digital twin technologies. Thanks again for being with us today. The floor is yours now. Thank you.
Thank you for having me. Hello, everyone. I am Selen Aksoy. I am a PhD researcher at Istanbul Technical University, and I will mention my research today. It's about residential adaptive reuse evaluation in urban context. Sorry. My presentation is structured in 3 parts. First, I introduce the housing crisis and the position of adaptive reuse within this context. Second, I will explain the methodological framework based on 15-minute city concept. Finally, I will present 2 case studies to demonstrate how this approach can be operationalized. Yes, the world is facing growing housing crisis, driven by housing shortage, supply-demand imbalance, and rising demand. And accordingly, UN Habitat by 2030, nearly 3 million people need access to affordable and available and accessible housing. And it means we need to produce approximately 96,000 new housing units per day. This scale makes it clear that new construction is insufficient and we need to find alternative way in existing urban fabric. In response to these challenges, this research asks actually as a main research question, can adaptive reuse be considered a housing production strategy within urban context? When we start to understand adaptive reuse, first of all, adaptive reuse is not a new strategy. It has been practiced from antiquity to Renaissance, and it was traditionally motivated by regional needs or heritage preservation. But after 19th, in many cities used this strategy for housing demand and sustainability targets. Especially after sustainability shift, this strategy gained attention again, and due to its environmental performance and potential to reduce carbon emission. And also, many research and many tools were developed during that period. And however, these are generally building scale assessments. For example, transformation meter is old and the most comprehensive one, but also it operates on server-based approach within a Vito system. And also it has locational investigation, but it has same limits and same distance standard for each buildings. And so adaptive reuse strategy cannot be considered in isolation from its environment, even if a building is suitable for conversion and transformation, but adaptation of the urban environment to the housing or the adaptation process is important for the adaptive reuse strategy. So evaluation of the strategy should be focused on urban daily life scale. We can use neighborhoods, we can use city boundary, we can use district boundary, but the more realistic, and we need to be more realistic, and we need to human-centered scale for evaluation. Because of this, 15-minute city concept was selected for this evaluation because it promotes sustainable urban living and includes urban functions structured around different dimensions. For example, density, proximity, diversity, and digitalization. To operationalize this concept, first of all, I used building level spatial data, and then created 15 minutes walking isochron with using Open Road Service API or another API, and then measuring and calculating we use urban data, multi-layer urban data. And then in this methodology, for evaluation framework, we create a multi-criteria score using some analytical model, or we can do also comparative analysis based on city needs and contexts. Amsterdam is my first case study. Amsterdam population has been growing, and to meet housing demand, the municipality has applied housing strategies. For example, one of them is new construction and other is adaptive reuse strategy. For this reason, Amsterdam provides a suitable case for comparison and evaluation of adaptive reuse possibilities in the city. In this research, I want to mention that I conducted this research actually with MIT Sensible City Lab, and also Amsterdam municipality give us some building data, and then we created a research question for this research. And do adaptive reuse or newly constructed housing have access to same number of amenities and same diversity of amenities in the city? We analyzed 554 buildings that were decided to build in 5 years. And then for Amsterdam, we applied 3 locational dimensions, 2 of them directly from 15-minute city concept, number of amenity and diversity. But last of them, tourist-related amenity, is extended of the 15-minute city concept because tourist-related amenities concentration is Amsterdam affects urban experience and residential experience and everyday accessibility, and people living in there is not happy for this. Starting this analysis, first we need to learn geospatial information of this building and housing units capacity in the city. And then amenities was classified based on 15-minute city theories and research. In here we use 9 types of amenities, such as art and culture, emergency, grocery, shop, restaurant, leisure, health, education, and service. And this amenities data was collected from OpenStreetMap with Overpass Turbo. To conduct this analysis, 15 minutes walking isochron using the Open Road Service API, as I mentioned before. And so we can see amenity density for each isochron, 2 type of housing strategy. At the policy level, the analysis was conducted at the district scale. Amenity numbers, diversity of amenity, and their changes over time were compared. The findings indicate that adaptive reuse buildings have higher number of amenities in total and central district. Also, they tend to generate stronger district level transformation in 5 years. When we talk about diversity, according to t-test results, adaptive reuse buildings isochron has lower diversity than of new constructed buildings isochron. To measure diversity of amenities, we applied Shannon entropy. And also we can see this result on district-based related with touristic amenity because diversity and tourist-related amenities show an inverse relationship in both type of housing strategy. We can also see that adaptive reuse buildings have more tourist-related amenities within their isochron. This is the reason for the lower diversity in adaptive reuse isochron. Also, the graphs indicates the higher concentration of restaurants and cafes and within adaptive reuse isochron. Also, which may help explain the decrease in diversity over the 5-year period because of amount of restaurant and cafe and maybe art and culture amenities. Looking at the score range, we can see that adaptive reuse buildings are able to produce more units in higher score, although new constructed buildings have more units in total, but they are mostly in the lower score ranges. And so the analysis indicate that adaptive reuse project in Amsterdam provide greater access to amenities and provide higher score housing units than newly constructed building. This is second case study. This is in Istanbul. Also, Istanbul has not limited number of adaptive reuse buildings for housing production, but last year, due to the housing crisis, the ministry has issued a regulation. This regulation aims to promote the transformation of office and shopping malls. Therefore, we evaluate buildings with adaptive reuse potential at the urban scale using the 50-minute city framework. We started this research question in here: which office and shopping mall buildings in city have high potential for residential adaptive reuse based on urban context indicators? This is a shopping mall and office buildings location in the city. We started this geolocation point, and then we used 4 locational dimensions in Istanbul, 2 of them based on 15-minute city concept, but connectivity and affordability is important for Istanbul urban life, and because of this we use this other dimension. In here we started 4 indicators data from different database. For example, first of all, we started to create a map, number of amenity, and then diversity of amenity, and then we created connectivity map for Istanbul based on some network analysis, and then we created affordability map for Istanbul. We used Google Place price level API, and then some rent information from real estate database. And also we created a indicator-based cluster map. And also this map provides us combination of indicator and understanding potential of isochron, and provide some information about implementation and needs after adaptive reuse decision. We can see different combination in different building types. And then we create, after all, using 4 indicators, create a potential adaptive reuse score. This map shows the distribution of potential adaptive reuse score actually across the building stock. Potential adaptive reuse score was constructed by, as I mentioned before, 4 indicators, but we can extend this. We can see high potential buildings and tier A and tier B appear concentrated in specific areas of the city, but this area also have tier D type of buildings, and actually this variation is related to difference in amenity access, diversity, connectivity, and affordability, and this finding also justified the use of the 15 minutes walking isochron as a framework in this analysis. May create sufficiency for capturing building level variations rather than neighborhood boundary or district level analysis. Also, we tried to compare for potential adaptive reuse score and housing units capacity, and we tried to create 4 clusters for the decision process. For example, buildings with high scores and sufficient housing capacity are suitable for transformation, of course, provided that building condition allow it. And also, we are working on some district level applications for some policy implementation. For example, this is the one of district in Istanbul, and we can see which building is better for adaptive reuse, which one is not a good opportunity for adaptive reuse decision in here. After all, in conclusion, the framework actually provides a scalable and extendable tool for planners, policymakers, and designers to identify and prioritize transformation opportunities. Thank you for listening.
Thanks for your lecture. Do we have any questions in the room? Feel free to raise your hand. I may have one, if I may. I'm just curious about your 15 minutes framework. And I was wondering if it would change or if it would be difficult or not to scale up to, as you said, the district area or even to the city. Is it like, what is blocking to do so? And why do you use mainly this 15 minutes framework?
First of all, 15-minute city provide us understanding walkable area, understanding, maybe I can say that understanding walkable digital twin. I don't know, but neighborhood and city boundary is very big for walkability and daily life access. But 15-minute city and 15-minute city theories provide us daily life accessibility and daily life experience in the city. And we need to understand before adaptive reuse decision, I think, understanding daily life experience in city and where is the hospital, where is the school, and where is the grocery, and I need to go there with walking, and because housing needs walkability in city, I think.
Yeah, okay, I see your point. I was just curious to understand if you change the scale, will your results be different in terms of number of rehabilitative building? Would you have like more option to more buildings? And would your results be very different or not if you change the scale?
Actually, in Istanbul case, we evaluated connectivity based on metro network system, and also we can add some different mobility, and for example, and train station, bus stop, and this is also prototype. And we only add a metro line system because of the database, and we try to create a framework only, and we can add some other mobility, for example, I don't know, maybe airports and maybe other connectivity things. And yes, it can be extend actually.
Yeah, okay, so we don't have like, all citizens of Istanbul are not 15 minutes from an airport, for instance. That's why I was wondering, and same for maybe hospital. So that's why I was wondering. And do we have maybe one or two questions? Yes. Let me bring the microphone.
Hi, thank you very much for the presentation. I am how do you define the origin point of these 50 minutes areas? So I think you mentioned just before that the connections are okay for the origin. what was the limit and how to start to define these 50 minutes areas?
Yes, 15 minutes city theory has some risk, but maybe connectivity and some affordability in Istanbul case, for example, creates more continuity for other 15 minutes isochron. I don't know, but this research is not about actually 15 minutes theory, and yes, it's a good theory or not, but actually we need to understand walkable and answer the daily needs for housing decision. And so we used 15 minutes city, 15 minutes walk shed isochron. And yes, 15 minutes is not good for some city. Maybe we can use 30-minute isochron. Maybe we can use 20-minute isochron. It's based on different city policy and some ministry regulation. But this is only experimental framework for understanding adaptive reuse decision, not only building assessments. We need to understand urban context. We need to understand daily life experience for adaptive reuse decisions. So, yes. Thank you for this question, actually.
I hope. I think we are really late and we need to go. So thanks again, Céline, for your participation and your involvement. And we can thank her again. So thank you very much. And this is the end of this series conference. So thanks again to all the speakers and to all of you who joined us today on site or online. And I think now the best thing to do is to gather on the hall for the lunch and to continue casual exchanges. Thank you very much and have a nice day. Bye-bye.
Thank you.